All right, friends, here we are for lesson 9. You're going to be using lesson 9 problem set in your math book. I'm going to be using the homework one just so that we're on the same topic, but maybe slightly different numbers. Today's lesson is comparing decimals. We want you to be able to think critically about what decimals mean in relation to each other. So when I'm looking at a number line and I have 0 to 1, there are 10 slots there. So if I have a 0.3 and a 0.11, I'm going to be comparing which one is bigger. Now, it might be tempting to look at 11 and say, well, I know 11 is bigger than 3, but that's what it is when it's in whole numbers, and these are decimals. So 0.3, 1, 2, 3, would be about right there, 0.3. But 0.11 would be 1/10 right here. There's 1/10. And then between 1/10 and 2/10, if I blow it up, there's 10 more little spots. So these are the hundredths right here. So 1/10 plus 1/100th is about right there. So it would be about right here, would be 1/10 and 1/100th. So when you look at in terms of that, we're not looking at 3 and 11. We're looking at 3/10 and 11/100ths. And in that situation, 3/10 would be bigger. So as we go through this lesson, the reason we're going through it this way is so that you can really have a picture of what the decimals look like when they are compared to each other. Directions say express the lengths of the shaded parts in decimal form, and then write a sentence that compares the two lengths. To use the expression shorter than or longer than in your sentence. So if we look at this one, I have 1, 2, 3, 4, 5, 6 pieces right there. And then this is divided into hundreds right here, and I have 8 of those. So it would be 0 and 6/10 and 8/100ths, 0.68. This one, pretty straightforward. 1, 2, 3, 4, 5, 6, 7. I have 7/10, so it would be 0.7. Well, which one of those is bigger? Well, when you look at them in the tape diagram like this, you can see that 0.7 just edges out 0.68. So 7/10 is just slightly bigger than 68/100ths. And so what I can say for my sentence is 0.7 is longer than 0.68. And you could also say it the other way. You could say 0.68 is shorter than 0.7. Let's look at this one. 1, 2, 3, 4, 5. So this is 0.5. If I look at this one, 1, 2, 3, 4. Then how many hundredths? 1, 2, 3, 4. So 0.44, just like that. And again, which one is longer, which one is shorter? I can see that 5/10 just is that much bigger than 44 hundredths. And so I could say 44 hundredths is shorter than 5/10 when I'm making my sentence. And it says list all 4 lengths from least to the greatest. So from least to the greatest. So least would be the smallest. So I'm looking at 4, 5, 7, and 6, and I see that 4/10 is going to be smaller than any of those. So it would be 0.44. And then my next one would be 0.5, which would be 5/10. And then of these two, it would be 68 hundredths and 7/10. Pretty straightforward. On the next page, I'm going to be examining mass, and mass is how heavy something is. And it's shown below in kilograms. We're going to put an X over the items that are heavier than the volleyball. And the volleyball is right here. And the volleyball is 0.25 kilograms. And it says to put an X over the ones that are heavier than the volleyball. So as I look at the ones that are heavier than the volleyball, it would have to be bigger than 0.2. So I know that 0.4 is going to be heavier. And I know that 0.6 is going to be heavier, but the basketball is 0.1. That's going to be shorter. And if you look at where the dials are, this dial is here and the soccer ball is heavier. The volleyball is here and the basketball is heavier. The volleyball is here and the baseball is lighter. And we're going to express that mass in terms of the place value chart. So the baseball, 0 ones with my decimal, 1/10 and 5 hundredths. So 15 hundredths in kilograms, 15.15 kilograms. Sometimes your mouth is going to get mixed up as you say it, but it will all work out. 0.25 kilograms, and so on and so forth as you fill them out. The basketball is 0.62 kilograms. The soccer ball is 0.43 kilograms. Again, very straightforward. Now, as we look at C right here, it says the soccer ball is, and they want us to use the words heavier than and lighter than in our statement. So the soccer ball is lighter than or heavier than the baseball. Well, we can see right there that it is heavier than. And you'll just be writing it in the line. And then the volleyball right here, the volleyball is lighter than the basketball because you can see it doesn't weigh as much, and you can tell by the dials, and you can also tell by the decimal number. And so you'll be filling that one out. And we're going to look at volume. Volume is just how high the water level is in each of the graduated cylinders. And there are several cylinders here. So we can record it on the place chart below. So cylinder A is right here, and it is 0.7. Doesn't have any hundreds. B has 0.62 liters. C, the cylinder has 0.28 liters, and D has 0.4. E, and again, this is just a matter of making sure that you're matching them up. 0.8, 5 hundredths, and F has 0.2. I don't have to put a 0 after it, that's sort of implied. So now I'm going to be comparing using greater than, less than, and equal to. So I've got 0.4. Is that greater than? So here's 0.4, greater than or less than 0.2. Well, I can look at just looking at the picture, and I can tell that 4/10 is greater than 2/10. Looking at this one, I've got 6/10 and I've got 7/10. Well, just looking at that, I can tell that the 7/10 just slightly edges out the 6/10. So the bigger part of the number is going to be at the 7. The smaller part of the arrow is going to be at the 6. The bigger part of the arrow will be at the 7. The smaller part will be at the 6. And then I've got 2/10. Now, looking at this one, I've got 2/10 and 2/28 hundredths. Well, this 2/10 is 2/10, and this is 2/10 plus 8/10 more. So that one is going to be just slightly bigger than 2/10 because it's got this 8/100ths more than the 2/10 right there. Then it says write the volume of water in each graduated cylinder in order from least to the greatest. So from least to the greatest, I'm going to use my metric symbol there. The smallest one I have right here is 0.2 liters. And I know that because I just did this one. The next one is going to be 0.28 liters because that one is just 8/100ths bigger than that 2 liters. So I've done that one. I've done that one. The next one I've got looks like it's going to be this one, 0.4 liters. The next biggest number in the tenths, I'm looking at the tenths. Oh, I've got a 6/10 there. 0.62 liters, 0.7 liters, and 0.85 liters. This lesson, pretty straightforward. If you have any questions, go ahead and ask Mrs. Sistey and I. just keeping in mind that you're remembering how we compare them and what that actually means when we're looking at the visuals of it. All right, guys, talk with you later.